Man, ever since we started this technology, it's been kind of weird. Like, take for instance Zoom. I start out with a simple meeting. It might be me and maybe three other people. Next thing I know, those one person called two people, another person called three people, another person called four people. Now we have just an outrageous amount of people on the phone or on the Zoom, excuse me. So it always start out with me. I might call somebody else. Then we might call maybe one or two other people. You see how this is resembled to the model that I showed you earlier? Next thing you know, we got multiple people there. By the end of the day, this is how our meeting is looking. So, imagine what technology is doing. And imagine how many people came just from one person calling three people. So, with that on your mind, I want you to understand this is very similar to what a factor tree is. And that's what we're going to focus on. So, what will the factor tree for 240 look like if you start the tree with a different factor pair? Now, we're going to check our prediction by creating another factor tree for 240 that starts with a different factor pair. First, we'll circle the important numbers, which will be 240. Underline the question. What will the factor tree for 240 look like if you start the tree with a different factor pair? And finally, we will box in keywords. Factor tree. Different factor pair. Okay, let's get ready to start doing the computation. Now, the first step is we will find a factor pair that consists of at least one prime number. We'll circle our prime numbers in our factor tree and divide our composite numbers. We'll check our work using the factor form as well as the exponential form. Now, what is a prime number? I know a lot of y'all want to know, what is a prime number? A prime number is simply a number that can only be multiplied by itself in one to get the sum of it. Like, think about 1 times 3. It gives us 3, but I can't think of any other two numbers that I can multiply to give me 3 evenly. 1 times 5. Can't think of any other number or any other whole number that I can multiply that will give me 5. 1 times 7, there's no whole number that I can multiply that'll give me 7 evenly other than 1 times 7. So 1 times 11, there's no other number that you can multiply to give you 11 except 1. So I hope you got an idea of what what the prime numbers are. If you need, you can pause the video right here so that you can record these numbers. All right, now that we know what prime numbers are, what is a factor? A factor is a number which multiplied by another number, it gives a product. So 2 times 5, it gives us 10. Our two factors in the equation is 2 and 5. Our product is 10. Now all numbers have one pair of factors, 1 and itself. Every number that you multiply, if you multiply by 1, you will get that number. So all numbers have that particular pair. Now, numbers are two types. Prime numbers that only have that one pair of factors, which is 1 times itself. And then you have composite numbers, which is more than one pair of factors, meaning that you can have multiple ways of getting the product of that number other than 1 in itself. Factoring 15. Let's use this for a good example. 1 times 15 equals 15. That was the common law that we just read earlier, that any number that you multiply by itself times 1 will give you itself. Okay, so 3 times 5 gives us 15. So we have more than one factor pair. So this means that we have a composite number. And the factors of this number is 1, 3, 5, and 15. Now the proper factors of 15 will actually be 1, 3, and 5. Okay, teacher's expectation or the teacher's exemplar. I like to call it Moody's Corner. All right, so we're going to use a factor tree to find the prime factorization of 240. We're going to list the factor pairs of 240. Do not make this very difficult. The factor pairs are simply 1 times 240, 2 times 120, 3 times 80, 4 times 60, 5 times 48, 6 times 40. All of these numbers paired up, multiply together to give you 240. Okay, so that's what makes the ordered pair. Or excuse me, not the ordered pair, but the factor pairs. Okay, now the numbers that I'm gonna focus on today when I start off, I believe I'm gonna start off with 10 times 24 because that looks very easy for me to factor down. Now, we're gonna choose any factor pair to begin our tree. Like once again, I did say I'm gonna start off with 10 times 24. However, if a number in this pair is prime, we're gonna circle it. If a number in the pair can be written as a product of two factors, we're gonna draw additional branches and write the factors. We're not gonna make it hard at all. Now, once again, what are the factored pair? The factor pair are just simply the numbers that can be multiplied together to give you the product that you're looking for. So we have 12, the factor forms of 12. Well, 6 times, -6 times -2 gives you 12. 3 times 4 gives you 12. -3 times -4 gives you 12. 12 times 1 gives you 12, and so on. So the factored pair is simply the two numbers that you multiply or the two factors that you multiply to get you the product that you're looking for. Now here, I want to try to show you very quickly. We can use a timetable chart to also help us. If you can identify 3 on the upper on the top of the page, and if you can go down to the number 12, and then if you can go over to the number 4, you'll see that 3 times 4 gives you 12. Now, on this ordered pair, I'm looking for another ordered pair that could give me 12. And I see that 4 times 3 will give me 12. I also see that 2 times 6 and 6 times 12 will give me 12. So you see how you can find your factored pair looking at a multiplication chart or a multiplication table. Let's move on. Now, the biggest thing you need to understand is that factors are multiples. Factors are simply just the multiples of the product. So 5 is a factor of 20, 4 is a factor of 20, 5 times 4 gives you 20. Now let's focus on 240. And let's make a list factor on our table, okay? So we're gonna just basically list all of our factors in a table. All right, we always said 1 times 240 will give us 240. 2 times 120 will give us 240. 10 times 200, 10 times 24 will give us 240. And 12 times 20 will give us 240. Let's move on. So we're going to start out with 240. And the way we're going to do this is we're going to find a factor pair that consists of at least one prime number. We're going to circle all prime numbers and divide our composite numbers. We're going to check our work using factor and exponential form. Starting off with 240. Going to make my branches. And I told you I'm going to start off with my factor pair of 24 times 10. Now, I'm going to start breaking down 24. It's the bigger of the two composite numbers. So, if I divide 24 by 3, I will get 8. Now, let's divide 8 by 2. And if I divide 8 by 2, I will get 4. Now, if I divide 4 by 2, I will get 2. And 2 is a prime number. I cannot go any farther. Let's jump over here to our composite number, which is 10. Make my 2 branches, and I know that 5 times 2 will give me 10. And both of these numbers are prime. So next I will circle all prime numbers. 3 is a prime number. 2, 2, 2, 5, and 2. Now I have all of my prime numbers circled. So let me try and see if I can get the same results if I use a different factor pair. Here we use 2 times 120. And if we look, we have 2 times 2 times 2 times 2 times 3 times 5. So it looks like we have the same factor form using a different factor pair. All right, let's not forget our rules. You always need to find the factor pair that consists of at least one prime number. Circle all numbers and divide all composite numbers. Check your work using factors and exponential form. Y'all, this time we use 12 and 20. And if we look, 12 is a composite number that breaks down to 3 times 4. 4 is a composite number and it breaks down to 2 times 2. 20 is a composite number. It breaks down to 4 times 5. 5 is a prime number, but 4 is a composite and it breaks down to 2 times 2. Y'all, when we write our answers in exponential form, that means we're writing 2 to the second power or 3 to the third power. Now, the way that we determine that is based off of our factor form. If we look at it, if we have 2 times 2 times 2 in our factor form, which is equal to 8 as a standard form, it basically saying that we'll have 2 to the third power. Okay? Factor form versus exponential form. Here, we use three different types of factor pairs to find out if our answer would be correct. All of them came with true. So we have 2 times 2 times 2 times 3 times 5. Now when we write this as an exponential form, we end up 2 to the 4th power times 3 times 5 gives you 240. And when we check our work, 2 times 2 is 4. 2 times 2 is 4 times 3 times 5. Now we all know that 4 times 4 gives us 16 times 3 times 5. 16 times 3 times 5 gives us 48 times 5, and then we end up with 240. Hey guys, when you finish up your work should look like this. You should have a list table. You should have listed your factors on the table. You should have written down your steps, step 1, step 2, step 3, and you should have solved this using 2 different ways of factor pairs. as well as writing the answer in factor form and exponential form and solving it back down to standard form. All right, guys, I'll see you at the next lesson. I hope I didn't talk your ear off too much. Have a great day.